Hello everyone, and welcome to the fourth tweet in the Learn Kubernetes in 10 Tweets saga. In this one, we're talking about the decoupled nature of Kubernetes in separating storage from the application that's running the storage. So because of this decoupled nature, a volume within Kubernetes can exist independently of a pod. And that's useful because, as we know, pods are ephemeral. So as the pod moves from one node to another, the storage will follow it as long as you have that in your pod YAML spec, as we see in this diagram here. So not only do we have a persistent volume, but we have a persistent volume claim resource, which act together to provide a way of accessing the backend, whether it's NFS or it's local storage, or if it's another device. There's many devices available, and then a persistent volume claim will access that volume and claim or reserve, so to speak, a portion of that persistent volume to use for the application. So these two are required in order to attach to a pod or deployment. In this diagram, we see a pod used to mount the volume to the pod, and we'll go through an example of it right now. So let's see what a persistent volume and a persistent volume claim look like. I'm just going to pull down a couple files here, which are the YAML for the persistent volume claim, and the pod-pvc and pvc and pv and pvc.yaml. And you can also access these files by going to the short link that I've created for you, which is secates.com/vol and secates.com/podvol. And so let's clear the screen and let's open up one of these files. So let's go to the top here of this file, which has the YAML for persistent volume. We've named it data-pv. The actual storage is going to be 10 gigs. And it's going to get that storage from the host path or from the storage on the node itself. And that's going to be located in the mount directory in the data directory. And if we scroll down, we have the persistent volume claim, which is going to reserve a portion of that persistent volume to use for our pod. And that is called pv-claim. And the access modes, which allow you to access the volume from one or many nodes at once. In this case, we have read-write once. So the data is only going to be read and written to once, and that's from one node at a time. And then out of that 10 gigs of storage that we provisioned using our persistent volume, we're going to request 5 gigs of that. So let's quit out of here and let's apply our configuration or create our PV and PVC by using the kubectl apply command and a -f and then the name of the file, so pv and pvc.yaml. So now we see if we do kubectl get pv, we see that we have that storage reserved and the status is bound, which means that a persistent volume claim has claimed it. And we can see that on the other end of it by doing kubectl get pvc. And we see that it's bound and the capacity is 10 gigs. And so we'll clear the screen here and then we'll take a look at our pod YAML, which is going to spin up a container inside of a pod and then attach the volume to it. So let's just go to the top here and we've named this pod pvc-pod. The volumes for this pod are going to be coming from that persistent volume claim that we just created, which is pv-claim, and the name of the volume is pvc-storage. This can be any name you want, but the only thing that has to match here is the name of the volume and the name of the volume mount. So if you notice this last line here, the name of the volume mount is pvc-storage as well. So then we're just going to spin up an Nginx image and name the image or name the container pvc-container. And we're going to expose port 80 and name that port or the exposing of that port HTTP server And then the mount path is going to be user share nginx HTML. And this is important because this is going to be the directory in which that storage persists. That's going to be the location on the container. So we'll go ahead and apply this as well. So kubectl apply -f and then the name of the file, pod-pvc. And then we can do kubectl get pods to see our pod running. And then we can access our pod. So to view what's inside the container, we can do kubectl exec it, which means interactive and terminal together. And then we'll specify the name of the pod, which is pvc-pod. And then we'll do a -- to signify whatever comes after this is the command that you want to run on the container. In this case, it's a shell. I want to get a shell inside of the container. So here I am. I'm going to change directory to that path that we specified in the pod YAML, which is user share nginx HTML. And if we list the contents of this directory, we'll notice that it's empty. So let's go ahead and just insert something in here so we can prove that the data will persist beyond the life of the pod. So let's do a simple index.html file here. So let's echo, this is my homepage. And so now we have this index.html, or cat rather, sorry, index.html. And just says this is my homepage with basic HTML. And so let's exit out of this container now. And now let's go ahead and delete this pod. After we delete it, we'll recreate it and we'll see that that file still exists, even though it's a brand new pod. So we'll do kubectl delete pod, and the name of the pod is pvc pod. And let's clear the screen, and just to make sure we don't have any pods running, there we go. Get pods responds with no resources found. So that means we need to create a new container, and we can create a new container with that same pod YAML. So we'll do kubectl apply -f, and the name of the YAML was pod-pvc.yaml. And now kubectl get pods gives us a new pod. And so we'll exec into that again, kubectl exec it, and then the name of the pod, pvc pod, and then shell. And then we'll change directory into user share nginx HTML. And we'll see there's our index.html file. So that's persistent volumes in a nutshell, and allows the persistent storage to automatically attach to pods regardless of whether they've been deleted and recreated on one node or another.